We will continue the presentation of CSEC Multiple Choice Practice Paper 7 with Part B, another 15 problems. These will take us from problem number 16 through to problem number 30. A man bought a car for $200 and sold it for $250. What was his gain as a percentage of the cost price? A man bought a car for $200 and sold it for $250. What was his gain as a percentage of the cost price? Percentage of the cost price, that is being highlighted because unless otherwise stated, profit or loss is always given as a percentage of the cost price. The problem requires the gain as a percentage of the cost price. Probably the simplest way to solve this problem is to write the selling price as a percentage of the cost price. The selling price as a percentage of the cost price. Like so. Cost price here, selling price right there, multiply by 100. Reduce the fraction by a common factor of 100. This may be done by striking off zeros, 2 zeros as a matter of fact, from both numerator and denominator. And we may have another step, which is to divide 250 by 2. We get 125, and that is given as a percentage. As we said before, write the selling price as a percentage of the cost price. Another operative word we are highlighting there again, which is gain. We now need to determine the gain. The original is always 100%. So the original is always 100%. The percentage that we have is 125. This means that another 25% was added to the original. The original is 100%. We have 125%. That means there was a gain in 25%. And that is what we are attempting to determine. We may do that or demonstrate that by showing that we are subtracting 100 from 125. The correct answer is option D, 25%. Generally, profit or loss is written as a percentage of the cost price unless otherwise stated, as we said before. Another take at solving the problem. In solving the problem, most candidates would subtract the selling price from the cost price. That is, subtract 200 from 250. That is how most candidates may begin. The result is the gain or profit. Let us then write that as a percentage of the cost price. So after finding the gain by subtracting the cost price from the selling price, then the candidate may proceed by finding the gain as a percentage of the cost price by making use of this process. The gain over the cost price multiplied by 100, and again reduce the fraction by a common factor of 100. And 50 divided by 2 is equal to 25. 25% is our correct answer, as we have right here. So we have verified that 25 is the correct answer. Now we have the sum of two fractions, a half and 1/3. How may we proceed with that problem? From our general experience adding fractions beginning in primary school, we should recall that the sum of a half and 1/3 is 5/6. So just by experience and by working with fractions over a long period of time, as soon as we see a half plus 1/3, we know the answer is 5/6. If we do not or cannot remember that, let us take a good look at the process so we will actually add them. The most important thing to note is that we are adding fractions with different denominators, and we may recall the procedure for such. We are adding fractions with different denominators, and we will recall the procedure for such from our primary school experience, finding the common factor, usually finding the lowest common multiple or the common denominator. The common denominator that we should use should be the lowest or the smallest number that 2 and 3 can divide into without leaving a remainder, and that will turn out to be the LCM of the numbers, and that is 6. Then we say 2 into 6 is equal to 3. 3 ones 3. Then we say 3 into 6 is 2. 2 ones 2. 3 plus 2 is equal to 5. The answer is 5/6. So by making use of common denominators, then we could have solved the problem. Also, there we have our answer, option C. On the next slide, we will place some of the algebraic operations under the microscope. We will take a look at some general and mental methods that may be used in adding fractions in a matter of seconds. On the next slide. A common denominator is 6. We may convert each of the fractions to one whose denominator is 6. So if we have a half, to convert this with a denominator of 6, we need to multiply the 2 by 3. 2, 3, 6. But that will not be correct unless we multiply the numerator by 3 also. So multiply both numerator and denominator by 3. And what do we see? The fraction is converted to 3/6. So we have 1 multiplied by 3 is 3, and 2 times 3 is 6. As we have in this statement here, for half, the denominator is 2. To make it 6, we need to multiply by 3. To cause the fraction to remain the same, we need to multiply the numerator by 3 also. So the fraction is converted to 3/6. One-third, taking the same approach. The common denominator is 6. In order to make 1/3 a fraction whose denominator is 6, we multiply this 3 by 2 to get 6. But cannot be legitimate unless we multiply 1 by 2 also. So multiply both numerator and denominator by 2. So we get 2 ones 2 and 2 3 6. So 1/3 is actually 2/6. So we have this statement here. For 1/3, the denominator is 3. To make it 6, we need to multiply by 2. To cause the fraction to remain the same, we need to multiply the numerator by 2 also. The fraction is converted to 2/6. I hope that by this process you see the real purpose of taking a common denominator, which is to arrive at fractions that have the same denominator. we know that when fractions have the same denominator, we may find their sum by adding the numerator and placing the result over the denominator. So they have the same denominator, we add the numerators and place it over the common denominator. So we have there 5 over 6. I think that by using this process more than any other, the purpose of taking a common denominator is more evident. That is, to get the numbers to have, or the fractions to have, the same denominator, in order that we may just manipulate the numerators in arriving at the answer. So if we could convert each fraction to a fraction with the denominator, which is actually the common denominator, then that is more true to life. Let us add 1 over 3 and 2 over 5. The common denominator is 15. To get 15, we multiply 3 by 5 and we multiply 5 by 3. We will do the same with the numerators. So let us take a look at what we will do. We have 1 over 3 and the common denominator is 15. To cause the 3 to be 15, we will multiply the 3 by 5 and multiply the 1 also by 5. So we'll have 5 over 15. So this one is actually 5 over 15. This one, 5, to convert this to 15, we multiply by 3. 5 3 is 15. We do the same with the numerator, multiplying by 3 also. So that will turn out to be 6 over 15. So this one will be 5 over 15 and the other one will be 6 over 15. So multiply 1/3 by 5 over 5 and multiply 2/5 by 3 over 3. Then the answer is 11 over 15, what we achieve by adding the numerators and writing that as a fraction whose denominator is the common denominator. Then there's nothing else to it. Your skills in the manipulation of fractions should have been developed enough for you to know that a half is equal to 3 over 6. 1/3 is 2 over 6. Also, 1/3 is 5 over 15 and 2/5 is 6 over 15, etc. The answers for the problems may be written down without a stroke of the pen. If you can manipulate fractions in that way mentally, then you will be able to breeze through these fractions that we have in the CSEC multiple choice paper. Another important thing to know about the addition of fractions. When adding fractions, remember and make use of this general rule, namely, if the numerators of two fractions are equal to 1, their sum may be found by placing the sum of the denominators over the product of the denominators. So there we have two fractions and their numerators are equal to 1. Their denominators like that. Consider your previous two fractions. Their numerators are equal to 1. Add the denominators and place the result over the product of the denominators. So 2 plus 3 and put that over 2 times 3. Do not worry, it works every time. Physics students have been using this concept in finding the effective resistance of two resistors in parallel from ever since there was a resistor. So do not think that this is magic or this is a failed attempt at being smart. This method or this principle has been in use a very, very long time. and it has a wide variety of practical applications, like for capacitors in series and also resistors in parallel. So do not worry, it works every time. Physics students have been using this concept in finding the effective resistance of two resistors in parallel from ever since there was a resistor, and maybe also for capacitors in series. The effective capacitance of capacitors in series from ever since capacitors have been placed in series. If one of the denominators is a multiple of the other, the answer will still be correct. So the denominator 10 is a multiple of 5. Do the same. Add them and put that over the product. So 15 over 50. What happens? Common factor in numerator and denominator. So we proceed to reduce by a common factor of 5. The only additional consideration is reducing the answer to its lowest terms. This may be done by reducing the numerator and the denominator by a common factor of 5. 3/10. Since 10 is a multiple of 5, it means that 10 is the common denominator. We could take that route. To move from a denominator of 5 to a denominator of 10, we need to multiply by 2, and we will do the same in the numerator. So we do the same with the numerator, and the fraction becomes 2/10. So 1/5 is actually multiply this by 2, multiply this by 2, we get 2/10. And they have now the same denominator, so we just add the numerators, and that's all there is to it. So in finding the sum of two fractions with their numerators equal to 1, add the denominators and place the result over the product of the denominators, and that's all there is to it. If one denominator is a product of the other, the treatment is the same. Okay? However, at the end, you will realize that the answer that you get will be able to be reduced by a common factor. There is no harm in that. The answer is still correct. A salesman is paid 5% of his sales as a commission. His sales for last month were $2,020. How much commission was paid? 5%. This problem is too easy to be true, as if all problems should take 2 pages of a police record book. We may first solve the problem by applying a bit of mathematics. A strategy for multiplying by 5 is to take half of the number and increase the result by 1 place of decimal. Take half of the number and increase the result by 1 place of decimal. Half of the number and increase the result by 1 place of decimal. So 2020, take half of it is the same as dividing by 2, we get 1010. Now increase by 1 place of decimal, we get 10,100. Do not forget that 5 is a percentage. The result must be divided by 100, reducing by 2 place of decimal, and we have $101. The correct answer is option C. That's all there is to it. Alternatively, we may find 5% of 2020. 2020, find 5% of that. What do we know? Fraction may be reduced by a common factor of 20. Yes, of course, we see 20, we see 20. So 20 into 20 is what? 1. Then 20 into 2 is 0 before we say 20 into 20. Because some students may do that. They may say 20 into 20 is 1, and then 20 into 20 is 1 and end up with 11. But we should say 20 into 20 is 1, then 20 into 2 is 0, followed by 20 into 20 is 1. So we have 1, 0, 1 instead of 11. Then we may reduce by a common factor of 5. We may have a further reduction by a common factor of 5, and that is what we get. On the next slide, we will take a look at how we may make quick calculations when dividing by 5. So we are showing on the next slide, we will be showing on the next slide how to make quick calculations when we intend to multiply by 5. 5 is equal to 10 divided by 2. This fact may be used to multiply by 5 very quickly. So 5 is 10 divided by 2, and that is the fact that we are using to multiply by 5 very quickly. Dividing 368 by 2 may be done mentally by taking half of 36, which is 18, and half of 8, which is 4. The result is 184. Multiply that by 10, we get 1840. So in multiplying this by 5, the result will turn out to be 1840. How do we do that multiplying by 5? Take half of this, which is 184, and then append a 0 to it, 1840. That's all there is to it. Therefore, the speed with which one may multiply by 5 is limited to the speed with which we may find half of the number. Half of any number may be found very quickly. Therefore, we may multiply any number by 5 very quickly. So that 127 to be multiplied by 5. Half of 127 is 63.5. Multiplying by 10 results in 635. And we are demonstrating here that 5 is 10 divided by 2. So any number that we get to multiply by 5, we may either multiply by 10 and then divide by 2, or we may divide by 2 and then multiply by 10, which is what we are opting for under these circumstances. Therefore, in multiplying by 5, we first divide by 2, then increase the result by 1 place of decimal, which is the equivalent of multiplying by 10. The equivalent of multiplying by 10 is to increase by 1 place of decimal. So if there is no decimal place, an additional trailing 0 will do. Maybe we have an example of that right here. We have 24.54 to be multiplied by 5. So taking half of that, half of 24, half of 54. So half of 24 is 12, half of 54 is 27. 12.27, increasing by 1 place of decimal, and the result is 122.7, and that is our correct answer. Therefore, irrespective of the form that the number is in, whether it has a fractional part or not, or it does not have a fractional part, but dividing by 2 will result in a fractional part, then that does not make a difference. We always divide by 2 and then multiply by 10, which is, multiplying by 10 is equivalent to increasing a number by 1 place of decimal. How much does a customer pay for an article marked at $50 if a sales tax of 6% is charged? Look at this harsh treatment. By looking beyond the surface of the problem, we may be delighted that the amount of money used is $50. Why is that so? a percentage is out of 100. This is a simple relationship. 50 is a half of 100. That may seem a little bit shady now, but we will see in the long run how useful the fact that the amount of money that we have here is 50, and that 50 is a half of 100. 50 is a half of 100. The amount of money must be half of the percentage. The percentage is 6. The amount of money is 3. We need to increase 50 by 3. 50 plus 3 is 53. The correct answer is option C. That's all there is to it. Just by looking into the problem, looking beyond the surface, 50 is a half of 100. Therefore, we have a percentage here that is 6. So the number that we are going to use must be a half of 6, which is 3. Add 3 to 50, and we are done. If this is too harsh, we may go ahead and find 6% of 50 and add the result to 50, as we always do in primary school. 6% of 50, what do we have? 300 to divide by 100. 6 times 5 is 30, and another 0. So 6 times 50 is 300. Divided by 100, we get 3. Then we add that to 50, we get 53. The correct answer is option C, as we have determined before. Maybe if we place them side by side, the relationships between the amount of money and percentage will be a little plainer. First, consider that the original is 100%. So, $50 placed beside 100%. That is half. We can see that. What else do we know? The sales tax is 6%. Right. So, this is half of this, and what is to go here must be half of 6. So 50 is half of 100. Therefore, the amount of money that 6% represents should be a half of 6. 3. Some candidates may want to use ratios in solving the problem. Go straight ahead, no problem. However, if they take a second look at the initial setup in a method in which ratio is used, it will be seen that the answer is 3 before the process begins. So you are setting up a problem to use ratio. You put x right here. As long as you keep your eyes open, you should see that this is a half of this. So this must be a half of that. So while you are setting up your problem in order to make use of ratios, keeping your eyes open, you would not bother to use ratios because you would see the answer very quickly before the process begins, as long as you keep your eyes open. Ratios and proportions are very powerful tools and may be applied to a variety of problems in mathematics. Some problems that may seem to be very tough may be easily cracked down by simply using ratios. This is like the David and Goliath scenario. The problem may be solved in another way. So another way is by considering that the original is 100%, to which we will add 6%. This results in 106%. 106% divided by 100 will give 1.06. Therefore, increasing by 6% is the same as multiplying the original by 1.06. The sales tax will be added to the amount of money. So the 6% will be added to the original, which is 100%, making it into 106%. 106% is 106 divided by 100. And what is that equal to? That is equal to 1.06. Therefore, increasing by 6% is the same as multiplying the original by 1.06. 50 multiplied by 1.06 is equal to, what do? Multiply the numbers first as if there is no decimal place. So 50 multiplied by 1.06. Multiply as if there is no decimal place. So there we have it. 5,300 is what we get if we multiply all of these as if there is no decimal place. And what do we do next? The problem has two places of decimal, and so will the answer. So 50 multiplied by 1.06 will actually be 53, because we are multiplying without applying decimal places. Then at the end we will count the number of decimal places. In the problem we get 2. The answer should have 2 places of decimal also. That makes our answer 53. We may also find 106% of 50 without using a decimal fraction. So we did not have to use the decimal fraction as a root to the solution of this problem. So what do we have there? We have 106%, which is 106 over 100, and that we are multiplying by 50, or 50 over 1, and we have 5,300 over 100, reducing by a common factor of 100, we get 53 as before. So irrespective of the one that we choose from a wide variety of approaches, the answer will turn out to be the same. The 106% that we have right here and also right here is what we received by adding the sales tax of 6% to the percentage of the original, and the percentage of the original is always 100%. So 100% plus 6%, 106%. The exchange rate of one United States dollar is $2.70 in Eastern Caribbean currency, and we have that represented right there in brackets. What is the value of US $4.50 if we convert that to EC currency? Just begin by taking a good look at the rate. Just take a good look at the rate, and what do we know? On the US we have $1. On the EC we have $2.70. By considering the relative sizes of the figures in the rate, it is obvious that a conversion between the currencies will result in a larger figure for EC currency, or conversely a smaller figure for US currency. So any conversion will result in, if we are converting from US to EC, 2.7. The figure that we are going to get if we transfer US to EC should be larger than the figure that we have for the US. And if we are converting EC to US, because this number is larger than the one over here, the answer that we get over here should be a smaller number. We are converting from US to EC. Therefore, the result must be a larger figure. We will therefore multiply the amount in US, $4.50, by the exchange rate of $2.70. And what do we know? There is no need to go through the process. Multiplying the two non-zero digits, 7 multiplied by what? 5 is equal to 35, results in a number that ends with a 5. The correct answer is 12.15 or $12.50, and that is represented by option D. So instead of multiplying this all the way through, we may take advantage of the fact that by the time we start multiplying 7 by 5 we get 35. There is only one of the options that has the rightmost digit equal to a 5. Therefore, it has to be the correct answer. No difficulty in doing that. As soon as we begin, we realize that our answer should end with a 5, and this is the only one that ends with a 5. We did not have to finish the multiplication process at all. That is the beauty with multiple choice. All of the answers are there. The only consideration with these types of problems is this case in which the rate is given as a fraction that is less than 1. We need to be aware that in such a case, dividing by the rate will give us more and multiplying by it will give us less. So sometimes the rate is given not like this, but maybe we have $1 on the Eastern Caribbean side, and on this side we may have like 0.75, say, because 0.75 is a fraction that is less than 1. When we divide by 0.75, the answer is going to be greater than the number that we are dividing into. That number we call the dividend. So when we divide by a fraction that is less than 1, the answer is greater than the dividend. So dividing in that particular case gives a larger number, and that we need to be aware of. Of course, multiplying by a number that is a fraction that is less than 1, multiplying by that also will give us an answer that is less than the multiplicand. Same problem, different treatment. For most candidates, conversion between currencies is done at the snap of a finger. However, we may use devices that may guarantee the accuracy of the answer. In solving this problem, we may use a table as a guide. There we have the table. The table will now indicate the rate of exchange. So the first thing that we place in the table is the rate of exchange. And we try to cause the table to be consistent throughout. We have the amount in US. So the amount in US is placed there, $4.50, and we need the amount in EC. Considering also in the table that we have the rate, what do we know? According to the figures that depict the rate in the table, the smaller figure is on the US side. The conversion must therefore reflect the same. So the smaller figure is on the US side. So when we convert this to EC, the answer that we arrive at on this side is larger, or should be larger, than the one that we have right there. Just being consistent with the table. So the table is used there for us to maintain consistency and also increasing the likelihood that we would have calculated the answer correctly, by making use of the fact that if we are using this tabular form, every number that we have on this side should be less than its counterpart on this side, and every number that we have on this side should be greater than its counterpart on that side. And that consistency that we are desiring to maintain in the table will have a tendency to increase the accuracy of our answer. Using the table is not a must. Just look at the rate and take note of the relative sizes of the numbers. The larger number is on the EC side, which is the right hand side in this particular case. When performing the calculations, larger number should also be on the EC side, which is the right hand side. What do we know? Ratios may also be used in solving the problem. US to EC ratio, what do we know? 1 to 2.7. The other, so we have first EC here and US here, so US to EC. Then we have the US is 1, the EC is 2.7, 1 to 2.7. Then we may go a little bit further, placing in another ratio the amount of US that we have and the amount of EC that we need to convert this US to, which we do not know, so we will call that X. So the other will have the amount of US that is to be converted and its equivalent in EC. That we do not know, and we will call X. Form two fractions and equate them. So we have 1 over 4.5 and 2.7 over X. Then we will eliminate the denominators by multiplying by 4.5x, or we may flatten the equation. Flatten the equation will give the following result. We will have this x multiplying here and this 4.5 multiplying here, but that's not cross multiplication, that's eliminating the denominators. So the result is what we had from the beginning, multiplying $4.50 by the rate of exchange, which is 2.7, and the answer is the same. The result is the same as before. Using mathematical devices is not a necessity. Everyone should be comfortable converting between currencies without much hassle. However, if the devices make you more confident, then use them. If the simple interest on $800 for 3 years is $54, what is the rate of investment per annum? We have the interest, the time, and the amount, which is the principal, but we do not have what? The rate. So we need to determine the rate. This is another simple interest problem in which the simple interest is already given and we need to find the rate. Including 100 in the formula for simple interest is a redundancy, as we have stated before, because the rate is already a percentage. Let us write down the formula for simple interest. And that is equal to principal times rate times time. Making R the subject may be achieved by dividing the left-hand side by the product of the principal and the time. So the rate is equal to the interest divided by the principal and the time. If we need to make the rate the subject, we need to divide the entire equation by pt. By so doing, P and T will be eliminated from the right hand side, and on the left hand side we have the interest over the product of principal and time, and that is equal to the rate, or what the rate is equal to. We have the principal is 800, the time is 300, and the interest is $54. Making that substitution and simplify, the fraction may be reduced by a common factor of 2. 427. We may have a further reduction by a common factor of 3. 1, 3 into 27 is 9. The answer is the fraction 9 over 400. Since rate is expressed as a percentage, that is the rate that we have right there. The rate is what we have here. But rate is expressed as a percentage. Since that is the case, we will convert the fraction that we have there to a percentage by multiplying by 100. And what do we know? Then the fraction is 9 over 4. So the fraction turns out to be 9 over 4, which is equal to 2 1/4. The correct answer is option B. Mary invests $200 for 3 years at 5% per annum. John invests $300 at the same rate. If they both receive the same amount of money in interest, for how many years did John invest his money? By using common sense, we may determine that John invested his money for 2 years. How is that so? There we have the answer determined already, just by using common sense. Let us take a look at what we have there. Look at the figures 2, 3, 5. Consider the figures in Mary's investment. We see 2, 3, 5. John invested $300. In John's investment, we have what? $300. The same rate is 5%. If they are equal, the only number that is missing is 2. So, take a look. We have a 3 here and a 3 here. And do not forget that the rates are the same. So we have a 5 in Mary's. We will have a 5 in John's. So the 3 and 5 are common. If they are equal, then the other number in John's investment would have been the 2, which is the only one that would have been missing in order that the 2 could be equal. So we see 2, 3, and 5 in Mary's investment. Bear in mind that the investments had the same rate. The figures in John's investment were 3 and 5. So we have 3 and 5, and we have 3 and 5. These numbers are identical to those in Mary's investment, with the exception of the one that is missing. If the interests are the same, the missing number from John's investment has to be 2, since the end results have to be the same. So just by looking at it, we can tell that the answer is 2. With X being the unknown time in John's investment, let us write an expression in which the interest on both investments are equated. So call the one that we do not know, which is the time. Let us call it X in John's investment, and let us put 2 expressions for Mary's investment and John's investment, right, and attempt to find the value of X. So equate them, the interest on Mary's investment and the interest on John's investment. Take a look at them on this slide. Multiplying the entire equation by 100 will eliminate the denominators, so they are gone. Dividing an equation through by a particular common factor does not change the equation. Let us divide through by 100. This may be achieved in brief by striking off zeros from both sides, like that. 5 is also common on both sides. Let us divide through by 5 also. Lovely. If we are not careful, the 3's on both sides will go by unnoticed. Let us divide throughout the equation by 3 also. The only remaining factors are the 2 on the left hand side and the x on the right hand side. So those two must be equal. X is equal to 2. So if we equate them, the rate on Mary's investment and the interest on John's investment, then after reducing the equation, we have only x on one side and 2 on the other side. So x is equal to 2. Our answer is equal to 2. Although it may not be so important in determining the correctness of the answer, the numbers that cancel each other may be best crossed in the same way. This will help someone else to follow the steps that you used in solving the problem. Notice that 3 will cancel with 3, 100 cancel with 100, this cancels with this, and they are crossed in the same way. So if taking an approach like this in demonstrating the solution of a problem, then someone who is marking our paper will have no difficulty following the process, seeing how the fraction was reduced in order to determine with the greatest of clarity how the problem was actually solved. Of course, this is a multiple choice problem, and that kind of a scenario may not be of any great importance. But in the event that a problem like this is to be solved on an essay type paper, then such an approach may be considered. Now, what do we know? We need to square 8a. What we have there is just the square of a single term with its coefficient. In squaring a term, each letter or symbol involved must be squared. The coefficient must also be squared. So a has to be squared, 8 has to be squared. There we have it. In addition to that, squaring 8 is equal to multiplying two occurrences of 8. So 8 multiplied by 8 is 64. And we cannot leave this a squared out, so we have 64a squared. The correct answer is option D. The other answers are in line with the common mistakes that students make. They sometimes square one part and not the other. So they square one part and not the other, this one. They also may multiply a number by 2 when attempting to square it. This one, multiplying 8 by 2 to get 16 when attempting to square it. So that's another one. However, the mistake that I see most often in my work is that the symbol or letter is squared and the coefficient is not. I would have liked to see a distractor demonstrating this. The appropriate choice would have been 8a squared. We do not have 8a squared here. I'm just suggesting that that would have been a very good choice as a distractor, because in my work, the most common mistake that students make with this particular problem is that they square the a and not the coefficient. All that is required in solving this problem is for us to expand the brackets and combine the like terms. We will begin by expanding the brackets. Expand. 5 multiplied by 2x is 10x. Then what? 5 multiplied by a negative y, negative 5y. Then negative 2 multiplied by 3y, and that gives what? Negative 6y, and negative multiplied by negative is positive. So 2 5s 10. Negative 2 multiplied by negative 5x are positive 10x. Let us combine the like terms, if any. So 10x plus 10x is equal to 20x. And what else? Negative 5y with negative 6y, what do we know? Whenever we add numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. So adding negative 5 to a negative 6, we end up with a negative 11. We cannot always have it the way that we want, but of course I would have liked to see one of the options with a positive 11. And this distractor that we have here, a negative 11y, is, I think, a very good one, because some candidates may multiply a negative 2 by a negative 5, end up with a negative 10. So they have 10x minus 10x. Those terms will eliminate each other, and all that will be left is this negative 11, which we will have right here. So A is, as a matter of fact, a very good distractor. When adding numbers that have the same sign, add the values and the answer will take the same sign as the numbers that we have added. The correct answer is option D. Now we will multiply negative 8a by negative 3b. In multiplying algebraic terms, the first task is to multiply the coefficients. Do not forget that negative multiplied by negative is equal to positive. We will finish up by multiplying the terms a multiplied by b, which is equal to ab. How nice. The correct answer is option D, and we imagine that this is a very simple problem. The terms do not have symbols, or what we call, in this particular case, the symbols are actually letters. So the terms do not have any symbol or letter in common. We therefore do not need to apply any rule that requires us to manipulate indices. So we are not manipulating any index on this occasion. There we have a lovely one, number 26. 3x squared multiplied by 2x cubed. When multiplying algebraic terms, we simply multiply the coefficients first. So multiply the coefficients. Those are the coefficients. Multiply them, we get 2 multiplied by 3, and that is equal to 6. We are not done yet. We need to complete our task by manipulating the symbols or symbol, letter or letters. When multiplying numbers or letters that have the same base, we add the indices. So we have x squared, x cubed. Add the indices of the x terms, and what do we get? 2 plus 3 is equal to 5. So finally, simplify the result, we get 6x to the power of 5. The correct answer is option C. This may appear to be a simple problem. The fact is, some students are not aware of the simple rules that are used in the manipulation of indices. This is more evident when they try to make the transition into deciphering logarithms at the tertiary level. Logarithms are indices expressed in a different form. If you do not know one, it is next to impossible to know the other. So at the tertiary level, students are shown to be more vulnerable than at the secondary level. So when they get to this level, if they do not know the basics, the laws that are used to manipulate indices, then there is some difficulty that they will have when they try to decipher logarithms, because logarithms are actually indices and they are expressed in a different form. So at the tertiary level, if the law of indices, if those laws are not understood in the most minute detail, taking a look at logarithms may prove to be somewhat difficult. Here we have a binary operation. Sometimes students make a meal of a binary operations problem. This problem involves a binary operation. This is just an instruction given algebraically. Pay special attention to the details and we will have no difficulty. First, write the left-hand side of the initial algebraic expression and the problem that we are required to solve. The right-hand sides are written as templates. So, we have here the left-hand side M N. The right-hand side is a template, which is here. This is what will go here. And we have a template there. So we have M asterisk N and 5 asterisk 3. These two must be shown to have the same form. First, we have the product of M and N. We will therefore begin with the product of 5 and 3. It is as easy as that. What do we have next? Finish up with the square of N and hence the square of 3. Square of N, square of 3. Come on, what could be so simple? We need 5 multiplied by 3, that is 15, and we also need the square of 3, which is equal to 9. That's all there is to it. Now we need to take the square root of all of that, so we need the square root of 6. The correct answer is option A. A lot of students hesitate as soon as they come upon a binary operation problem. There's no need to be afraid. The operation is usually a rule that is given in a simple number pattern. Do exactly as the pattern suggests and you will be correct 100% of the time. And we have shown here that it cannot be so hard. Now we have a linear equation that we have placed over here under the microscope. We need to find the value of the unknown, which is x in this particular case. This is a linear equation with the occurrence of the unknown on both sides. Transpose them to the same side, preferably the right-hand side, where they can both be positive. The constants, which the numbers, will be on the left-hand side. Well, we may transpose this equation having the x's on this side, but that will cause them to be negative. In solving equations or transposing formulae, it is best to get the unknown to be positive or the proposed subject to be positive. That is always a good initial step. So we have x plus 3 and we have 50 plus 26. 76 is equal to 4x. The unknown x is accompanied by 4 on the right hand side. 4x means 4 multiplied by x. In order to eliminate 4, we need to divide by 4. Dividing through the equation by 4 will result in it being eliminated from the right hand side, and on the left hand side we have 76 divided by 4. Divide through by 4, 4 will be eliminated from this side, and 76 divided by 4, and that is equal to 19. Turn the beat around. It is always, although in this particular case no one can see because we are doing multiple choice, it is always important to have what? The proposed subject, or what we are attempting to find, ending up on the left hand side. That's all there is to it. The correct answer is option D. The option has some excellent distractors. They are designed to trap the candidates that falter in the manipulation of the directed numbers and those that slip with the signs during the transposition process. So these answers are actually very good distractors. If you slip with the signs, you may end up with one of them. And also if you falter with the manipulation of the directed numbers, it is possible that there is one of them that you will end up getting as your answer. Substitution. P is equal to m squared over 2 minus m. When m is equal to negative 3, as soon as someone sees the negative 3, they know that they get it wrong. Then P is equal to, that means we are attempting to find the value of P. Well, not quite. Making m a negative 3 does not guarantee that everyone will get it wrong. The best way to make substitution is to make use of a template. Yeah, make use of a template. We are in the computer age right now, and almost anything that you need. If you need a business letter of any kind, you have a template for it. So you will just take the template and you put in your particular information and you are done. Therefore, we should not have any difficulty making use of templates in mathematics, because making use of templates is natural these days. So make use of templates. P is equal to m squared over 2 minus m. Where we have m, we have this slot. Where we have it here, we have another slot. And this is our template. All we need to do is what? Substitute in the value of negative 3. So there we have the formula and the template designed accordingly. Let us substitute the value of negative 3 for m. That's it. A square is always positive. The square of negative 3 is 9. In the denominator, we have 2 consecutive negative signs. This results in a positive. So when we square a negative, the answer is positive. So negative 3 squared is positive 9. 2 minus a negative 3, we have consecutive negative signs there. That will be positive. So 9 over 2 plus 3, and that is equal to what? 9 over 5. The correct answer is option C. Apart from making the substitution and making sure that the negative signs are where they should be, we have the additional task of manipulating the signs accurately. Every year, I begin preparing students for examination with the topic directed numbers. The importance of understanding that topic cannot be overemphasized. At every step in mathematics, you will need that trusted friend. So we have quite a mouthful right here, that apart from making the substitution, the negative signs are to be manipulated accurately. That is a challenge of the problem. And I'm also saying that when I'm preparing students for CXC CSEC examination, I always begin by manipulating positive and negative numbers. Althea saved X each month, but in June she saved $4 more than twice her regular amount. How much did she save in June? So X each month. So let us first write down the amount that Althea saves regularly. She saves X dollars each month. In June, she saved what? $4 more. An additional $4. $4 more, an additional $4. 4 more, or $4 more, an additional $4. We therefore need to add 4. There we go. Adding 4. An additional $4. Lovely. More than what? We need to pay special attention to what the amount should be $4 more than. It is $4 more than twice our regular amount. Therefore, instead of adding 4 to X, we need to add 4 to twice X. So it is what? $4 more than twice her regular amount. $4 more than twice her regular amount. So we have the $4 more, an additional $4, but it is not to be added to her regular amount. It is to be added to twice her regular amount. Twice her regular amount is X, so we need to add 4 to twice X. Twice X is 2 times X, which is 2X. So throw in a 2 right there, and the expression is complete. The correct answer is option D, 2x plus 4.